Hello everyone and welcome back to the series of digital logic design or digital electronics. And now we will study a binary coded decimal. The binary coded decimal technique is a coding technique which is used for decimal digit and is based on straight binary assignment. The binary coded decimal is also known as BCD. In this method, a 4-bit code is used for representing a single decimal digit. Now, if you look at the table, we have a decimal symbol and corresponding BCD code. The BCD code is a 4-bit for each decimal digit. For decimal 2, we have a code of 0010, and for decimal digit 7, we have a BCD code of 0111. The binary coded decimal is an example of a weighted code. In weighted code, each bit position is assigned a weighting factor in such a way that each digit can be evaluated by adding the weights of all the ones in the coded combination. The BCD code for a single decimal digit have 4 bits, and these 4 bits have a weight of 8, 4, 2, 1 starting from the left hand side. And these weights correspond to the power of 2 value of each bit. Let's say we have a bit assignment of 0110. Now to interpret the decimal value, we will evaluate the weights, which will be 0 into 8 plus 4 into 1 plus 2 into 1 plus 1 into 0, and adding this will give a value of 6. So 0110 is a BCD weighted code of 6. Now if we have a number which have k decimal digits, the BCD code of this number will require 4k bits. For example, we have a decimal number of 396 which have 3 decimal digits. Now to make a BCD code, we will replace individual digit by the corresponding BCD code in the same order. Like starting from the unit place, we have a digit 6. So in the BCD, starting from the unit place, we will have 0110. Next digit is 9. So the next portion will be 1001. And the last digit is 3. So the next code will be of 0011. Now if you look at the code, each group of 4 bit represents one decimal digit. Now for any decimal number between 0 and 9, its BCD code is the same as its equivalent binary number, where for greater than 10, the BCD numbers look a bit different from the equivalent binary number, whereas both binary and BCD are strings of ones and zeros. Moreover, the binary combination from 1010 through 1111 are not used in BCD. Now consider another example. In this, decimal 185 is represented by its corresponding value in BCD and binary. For BCD, we know that we have to replace individual digit by its corresponding BCD code, and we will have to maintain the order. Like at unit place we have 5, so BCD will be 0101. Then we have 8 and its BCD is 1000, where most significant digit is 1, so its corresponding BCD is 001. So here we have a BCD code of 12 bits for 3-digit decimal number, whereas its corresponding binary number can be found using successive division by 2, and the table is shown here. So the binary code is 10111001 to the base of 2. We have a clearer difference in BCD code and a binary. Thanks for watching the video and stay connected for more interesting videos.